on 24, we worked out B yesterday. So if you weren't here, watch that video. It was like the last problem I did on it. When we have these inequalities, your goal, we talked about yesterday, you have to get a fraction on one side and 0 on the other. You cannot treat it like an equation where you just multiply the bottom over. If this were an equal sign, we would do that. Because of the inequality, we can't, because multiplying by a negative flips the inequality, and since there's that x, I don't know if it's positive or negative. So what we did is use a sign line to help us. Okay, you have to figure out what makes the top of this fraction equal 0 and what makes the bottom of the fraction equal 0. So that's where we start. We set the top and bottom equal to 0. So we get x equals -2 and -1/2. Okay, I am not making a real precise number line. You don't have to plot these things exactly. The fewer points you put on here, probably the easier it's going to be to make sense of it. So make sure, the only thing I really need you to watch is that your smaller point is on the left. Then we need to graph this. So when we did it, we talked about a couple different options. You could plug in test points, but I think most of you relied on your calculator from here, which is fine. So if I graph, you want to go with the original. You need parentheses around both the top and the bottom. Bless you. What we are trying to decide is whether this thing is positive or negative. That means positive is above the x-axis, negative is below the x-axis. So if I'm looking at this section of my graph, that would be positive. It's above my axis. So until I get to -2, my graph is positive. The -2 and the 1/2 are when we're going to switch. So after -2, what happens to my graph?
It goes down to negative.
And after -1/2, we had a vertical asymptote. That's why it just jumped up here. But this whole section of the graph is positive. Okay. Now I need to know which answers we wanted. So if you look, the original was less than or equal to 0. If you are less than 0, that means you are negative. So that's this section of the graph. Okay, equal to means bracket. But I can't put a bracket on both of those. Why? You have to watch something. If you have a fraction, what can never happen in a fraction? The denominator can't be 0. So can I plug a -1/2 into this? No. Whether it has an equal to or not, the thing from the denominator will always get a parenthesis because your denominator can't be 0. But because I have an equal to, the top could be. So my solution is bracket -2, -1/2 with a parenthesis. Is that okay? We worked 24B yesterday. Like I said, watch that video if you didn't get to see that. And in a few minutes, I'm going to do some extra review problems, so if we need to do another inequality, then I will. So the next question we asked was 25B. So all of the different types of asymptotes, let's kind of refresh that. So asymptote rules. Vertical asymptote is always x equals the number that makes the denominator equal 0. Okay, you can have more than one of those. So that's why we always would start by factoring the denominator, and then you can set each of those equal to 0. Horizontal asymptote happens a couple different ways. It's y equals 0 if the degree of the top is small. For instance, if it's like x over x cubed, the degree on top is just 1, the degree on the bottom is 3. So if the top degree is smaller, it's an automatic 0. You will get y equals a number if it's the same degree on top and bottom. In which case you divide the leading coefficients. Which I think we did one example yesterday, and that was the scenario. It was like x squared over x squared. So we divided those leading coefficients. All right, oblique asymptote. You're going to get a line, y equals mx plus b. And that's when the degree of the top is 1 bigger. So let's just go ahead. I know we only asked about 25b, but let's go ahead and talk about both of them if you guys don't mind. So on A, we have x plus 2. I would ask you to factor anything that you can. So x squared minus 9, that would break into x plus 3x. Okay. So vertical asymptote. X equals whatever makes the bottom 0. So what would make x plus 3 equal 0? Negative 3. What makes x minus 3? Okay, so we have two vertical asymptotes. X equals negative 3 and x equals positive 3. Remember when we graph those, vertical are up and down. So we would just have those dashed lines. Horizontal or oblique is based off the degree. What's the degree on the top? 1. On the bottom, 2. It was an x squared to begin with. Or if I FOIL that out, an x times x gives me an x squared. If the top degree is smaller, it's a horizontal y equals 0. Okay, the nice thing about these guys, a lot of times I'm going to ask you to graph from this. So when you put this in your graphing calculator, if the information you have written down and the information on your graph don't match up, somewhere there's a mistake. Either you plugged it in your calculator wrong, or you found one of your asymptotes wrong. So if those things don't match, take the time to figure out what's going on, okay? So on B, so vertical asymptote, x equals what makes the bottom 0?
2.
Okay, horizontal or oblique, what's the degree of the top?
2.
And the bottom? 1. Okay, so the top is 1 bigger, that means we have oblique. To find the oblique, we have to set up long division, but the good news is we don't have to do the whole thing. We just need a little bit of it. So it's oblique, so it's y equals mx plus b. We just need that line. So the x minus 2 goes on the outside. Inside I have x squared. If you would like, you could put a 0x just to kind of help hold place values. Bless you. And then we divide. What is x squared divided by x? X. Then you multiply. X times the x minus 2 gives you x squared minus 2x. Change our signs. Positive x squared and negative x squared cancel. 0x plus 2x is 2x. almost done. Now we're back to divide. What is 2x divided by x? 2. So our oblique is y equals x plus 2. That's all you need. You don't have to finish the division. Is that one okay? We didn't ask about 26. Do we need either of those? Graphing the polynomials. You know, we have to be able to tell me degree and behavior, zeros, whether it bounces or goes through, y-intercept, drawing a graph. Yeah, which one do you guys want? Let's do A. Okay, questions like these, you know, graphing, like 26, we talked about yesterday, 1, 2. Those questions are worth a lot of points just because there's so many parts to them. So make sure you know how to do those. You know, if you're talking about taking your final and you have a question where it's just solving an equation or a question where there's an A, B, C, D, E to it, this is definitely worth a lot more. Okay, so we have to know what we're doing on these. First thing is degree. Degree is like saying if I multiply this all out, what would be my highest power of x? Or if I'm looking at this, how many x's are there? There's x times x squared, so overall it's a degree of 4. Okay. Next question I'm going to ask is in behavior. So in behavior tells us which direction, you know, are both ends going up or down or one of each. It's based off the degree. Even degrees always look like a parabola. If there's a negative in front, what does that do to my parabola? Flips it upside down. So both ends are pointing down. Now, if you forgot that on your final, how are you going to figure it out? Graph it. Put it in your calculator and see which direction the ends are pointing. Okay, the zeros. That comes from setting each of these parentheses equal to 0. So what makes x minus 4 equal 0? What makes x minus 2 equal 0? What about x plus 2? And that would be a multiplicity of 2 because of the square. Multiplicity is like your exponent. Notice my degree was 4, that means there should be 4 zeros. And I got 4, 2, and negative 2 twice, so I got all 4 zeros. So the degree and the number of zeros you have should match. That's what degree means, is how many zeros. Okay, now we decide if we bounce or go through. So that is based off the multiplicity. Even multiplicity would bounce, odd multiplicity goes through. This is multiplicity, not the number itself. So these, if I don't have multiplicity written, it's 1. And 1 is odd. So we will go through at 4. We will go through at 2. And we will bounce at negative 2 because of that multiplicity 2.
So every time there's a multiplicity of 2 bounces.
Like even multiplicity. So 2, 4, 6, 8, any of those would bounce. Last thing I asked here is the y-intercept. Y-intercept is where you cross the x-axis, or sorry, the y-axis. We did that on the first page too, finding intercepts, and you just plug in 0 for the opposite variable. Bless you. So a y-intercept, you plug in 0 for all of your x's. So 0 minus 4 is negative 4. 0 minus 2 is negative 2. 0 plus 2 is 2 squared. And we get negative 32. I'm not having you guys find that stuff just for fun. I expect it all to be plotted on your graph. So if you don't actually put your y-intercept on your graph, you're going to lose points. I'm going to count by fives. -32 would be about there. My zeros, those are where you hit the x-axis. So we hit the x-axis at 4, 2, and -2. We said both ends are pointing down, so it should start down here and end down here. So let's try. So if we go, the first 0 is at -2, and what did we say happened at -2? Bounce. Remember when you draw these in, guys, it is curved. These are not just like V's or zigzags. It's a nice curve. What happens at 2? Goes through. And what happens at 4? So overall, the graph looks like this. Now, how can you check yourselves? Yeah, I'm not making you take this final without a calculator. Use your resources. You've got that calculator, plug it in and check it. Now, is it wise to just graph the original and try to guess all the information from there? No, because if I throw in some fractions or things, it's hard to tell that for sure on your calculator. So do it by hand. Check yourself with the calculator. If those two things don't match up, then start figuring out where you went wrong. Okay? Questions on this one? Okay, 27 just asked if it passed, or if it was 1-to-1. Remember, that means it passes the horizontal line test. And why did we care when things were 1-to-1? What can we find if they are? We can find the inverse. So 27, it is 1-to-1 because it passes the horizontal line test, which means we can find an inverse. 28 is actually finding an inverse. This is another one of those questions. There's not just a two-step process here. So this would be worth a few points. So finding the inverse. Step 1, you change your f of x to y. An inverse is like the opposite. So then what happens is the x and y flip roles. So your y becomes x, and all of your x's become y's. Now, what do we need to do? Solve for y. We want to put it back in function notation, so we have to solve for the y. So I'm going to multiply by my denominator. So the xy minus x equals 3y plus 2. I'm trying to solve for y. I have y in two places, so I need those on the same side. So I'm going to subtract over my 3y, and I'm going to add over my x.
Could you just take out x in that step?
If you did, it will take you right back to where you were going, because you're trying to solve for y. So using that thought, what should I do right here? Take out the y. If I pull out my y, then we have x minus 3. Then to get y by itself, what do we do? Alright, so final step here, instead of y, we did change it to f inverse, so we would say f inverse of x equals, bless you, 2 plus x over x minus 3. Then I might ask you about domains and ranges. Domain of the function. The x's in your original become the y's in your inverse. So the domain of the function and the range of the inverse are equal. if I look back at my original function, we have a fraction. If there's a fraction, we know the bottom can't be 0. So what can we not have?
Right.
So my domain would be negative infinity to 1, union 1 to infinity.
And what was that one where, like, if you get it, you know it's just negative infinity?
If it's not a fraction, so if it's
Okay.
just polynomial. Alright, the range of the original function. The y's in the original become the x's in your inverse. So what we did is we looked at the inverse and we found the domain of it. So what can x not be there? 3. So that would be a negative infinity to 3, union 3 to infinity. Questions there? Okay, so we have kind of gone through the entire study guide at this point. Videos have been posted from everything we've worked out. You know, you can come in if you have more questions. So what I would like to do with our remaining time is maybe work out some more review over the things that we worked the most points on the final, just to make sure that we've really got that. Your final, there are, kind of like last semester, I have some multiple choice questions and some short answer questions. Multiple choice is worth a minimum of 3 points per question. Some of them are worth more. So is it wise to just push some buttons on your calculator and circle an answer? No. Show me work. No matter what it is. If you're just graphing something on your calculator, draw me a picture of what your graph looks like. So that if you make a mistake, I can tell why you made your mistake and I can give you partial credit if possible. Okay, so you still need to show me work even on those multiple choice type questions. Some of the short answer questions, those are going to be your higher point value. There's not going to be as many of those, but those are these multi-step questions like we've been talking about. So let's just look at some samples. Okay, let's say I told you I'm going to give you that function. And then I would break down everything that I want. So I would say factor the numerator and denominator if possible. So can you factor 3x squared? Not really, so let's just leave it. What would you do on the bottom?
X minus
1, x plus 4. Okay, so that's your first step. Then I would ask you for your intercepts. So this is like that second question on your study guide. So make sure, write these down or look at them or go back and review the video before the final if you need to. How do we find an x-intercept? Right. So an x-intercept is what makes y equal 0. And we talked about how you would just multiply over the bottom, so all it's really saying is what makes the top 0. And what would we get here? 0. So our x-intercept is 0. How do you find a y-intercept? So if I put in 0 for all of my x's, 0 minus 1 is negative 1, 0 plus 4 is 4. So we get 0 over negative 4, which is 0. So x and y-intercept are both 0. Then I would ask for all of the asymptotes. So vertical asymptote, we talked about today. Isabella, we're just doing extra practice over some of the things that would be worth the most points on the final.
Okay, are those the only ones you went over?
Yeah. I did. I think I ended up working all of 25 and I worked 26A as
Did you
well.
do 22? It's
No.
easy. It's easy, but I have no idea.
Okay, we'll work that one in just a second.
Okay.
Okay, so vertical asymptote, x equals what makes the bottom 0? So if I'm looking at this, I have x minus 1, so what would make that 0? 1. We have x plus 4, so what would make that 0? So we have two vertical asymptotes, x equals 1 and x equals negative 4. Now we have to decide if it's horizontal or oblique. So what is the degree of the top?
2.
What about the bottom? If you multiplied out the bottom, though, it was x squared, so they're the same. You could look at the original for that too, if it's easier before you factor. If they are the same, we divide leading coefficients. So 3x squared divided by 1x squared. So 3 over 1 is 3. So it is a horizontal, y equals 3. Okay, then I would expect you to graph all of this. So we have our vertical at 1 and negative 4. Horizontal at 3, and I am going to be looking at your graphs and make sure you actually have all this stuff plotted where it's supposed to be, not just, a random horizontal line. Put it where it belongs. X and Y intercepts were both 0. And then how do we fill in the gaps? Graph it. I recommend graphing the original. That way if you've made any mistakes along the way, you'll kind of catch it. When you plug that in, you do have to remember parentheses around top and bottom. So the top was 3x squared over the bottom, x squared plus 3x minus 4. So if I look at it, it's starting up here, and then it's down here, and then back up here. And make sure, if the graph doesn't fit your information, what does that mean? Something's wrong. Either you didn't put in parentheses when you graphed it, or you plotted information wrong, or you found something, one of your asymptotes are incorrect. So take the time to go back and double check and see what went wrong if things don't match up. Is that one okay? Alright. So we did have a question to go back to problem 22 on the study guide, so let's do that real quick.
There's only 6 questions. I always have time for 6 questions. Like make me do it yesterday.
Don't tell me that.
It doesn't reflect on you, so it doesn't matter.
It doesn't reflect.
Don't worry about it.
Thanks, that makes me feel so much better.
You were my algebra 2 teacher. I didn't click B. I tried on 2 of them, but otherwise I just guessed.
Okay, so we have this graph. Domain and range. Domain is talking about your x's, so as you go from left to right. As I keep going to the left, this will keep getting wider. It's going to keep getting wider to the right. So what do we end up hitting?
Negative infinity.
Right, everything. Negative infinity to positive infinity. Range is referring to your y's. Okay, these ends are going down forever. So y's, we go bottom to top. It's going down forever, so we're hitting all those negatives, and it stops at a y value of 3. So negative infinity to 3, and the 3, we do actually hit it, so it gets a bracket. Okay, B, zeros. What are zeros? Yes, same thing as x-intercepts. This thing hits the x-axis at negative 3, and 0, and 1. see, I wanna know where f of x is greater than 0. So greater than 0 is above the x-axis, so it's right here. We always answer with an interval for the x's, so that's starting when x is 0 and ending when x is 1. Parentheses or bracket? Parentheses, because I didn't have equal to. If I had said where is f of x less than 0, where would that have been? Be from negative infinity to 0 and from 1 to infinity. Okay. Maximums and minimums. So right here, if a point is higher than the ones around it, that is a local max. It's not the highest on my entire graph, so it's not the absolute. You can list those different ways. You could give me the ordered pair if you wanted, so you could say that's -3, 0. You could write it function notation, f of -3 equals 0. I don't care. Either one of those mean the same thing. Do we have any other maximums? Right. This one, that is the highest on the entire graph. It is technically both a local and absolute. Absolute because it's the highest on the entire graph. Local because it's higher than the points on either side of it. Okay? So that one you could say it's about 3, or about 1/2, comma 3. Or you could say f of 1/2 equals 3 if you did function notation. Local or absolute mins. Do we have an absolute min on this entire graph? These ends keep going down. So is there a lowest point on the entire graph? No, but we do have a local min. We have a point that's smaller than the ones surrounding it. So my local min, that was at negative, I don't know what you want to call that, 3/2 or 4/3, something like that, comma about negative 8.5. If you were in the ballpark, I would give that one to you, because it is difficult to tell exactly. Somewhere between -1 and -2 for your x, and your y is between -8 and -9. Is that okay? Alright, so some more general review. Let's do this one. Okay. So this is kind of like question 1. So the first thing I'm going to ask you are the possible zeros. How do we find those? P's and Q's. Where did the P values come from? Constant. So what's everything that goes into 12 evenly? Okay. Q is the leading coefficient. So everything that goes into 2 evenly would just be 1 and 2. So then how do we find the possible? P over Q. So all of these get plus or minus. So 1 over 1, 1 over 2, 2 over 1, 2 over 2 is 1, I already have it. 3 over 1, 3 over 2. 4 over 1, 4 over 2 is 2, we've got that. 6 over 1, 6 over 2 is 3, we've got that. 12 over 1, 12 over 2 is 6, we've got it. Then what do we do? I'm going to ask you to find all the zeros in the factored form. So we need to graph this to kind of narrow down our list. This is everything that might work, so we need to find something that does. So I'm going to plug this in. When I say find something that works, what am I looking for on my graph? A 0 or an x-intercept. Okay. We just need one that works for sure. So you told me -4. So then we do synthetic. So 2 comes down, and it's a series of multiply and add. So 2 times -4 is -8. Add, we get 1. -4 times 1 is -4. Add, we get -3. Multiply 12 and we get 0, which we would expect because we said it was a 0, so you should get a remainder of 0. That's your remainder, your constant. This is like x and x squared. What can we do now? Just multiply to -6 and add to +1. 3, 2. So factor. So the 2 things I'm going to ask you are the real zeros. Zeros are just a number. We already know -4 is a 0. What would make x minus 1 equal 0? 1. What about 2x minus 3? Then I will ask you for the factored form. That's when you have those parentheses. So we have 2 of them right here, x minus 1 and 2x minus 3. How do I get the last one? Right. We knew -4 was a 0, so that would be an x plus 4. Remember, it's always x minus that 0, so it changes the sign.
How is it 2x minus 3?
Oh, you're right. I messed up, didn't I? That should be a +3, shouldn't it? I did that on purpose, see if you're paying attention. Isabella passed, the rest of you failed.
So for the last one, you just gotta do the first 0 you put in.
Yep, x minus that 0 from your synthetic division. No, it was originally an x cubed, so I have 3 zeros, I have 3 parentheses. Okay. What do we need? We could do one of the inequality ones, like problem number 24. We could do an inverse like 28, or we could do a polynomial graph like 26. Those are all higher point value things. What do you want me to work?
Could I do 1 like 26?
One like 26? Yep. So let's say I told you.
I just know I don't know.
Okay, the nice thing, I'm not just, throwing these at you and expecting you to remember everything we ever did. I will prompt you. I will tell you exactly what I want you to find. So I'm going to say, tell me the end behavior. Or actually, I might ask for degree first. But what is our degree here? 3. We have an x squared times an x, so it's a degree of 3. In behavior, okay, if it's odd, it looks like a cube. But I threw a negative in front of there, so what does that do to my ends? Flips them. So my end behavior should be up, down. If you're not sure, how do you get it? Graph it. Okay. Then I'll ask for your zeros and multiplicities. So does -3 ever equal 0? No, so we can ignore that. What would make x plus 3 equal 0? It's squared multiplicity of 2. And what makes x minus 4 0? Okay. Then I'm going to ask if you bounce or go through. So at -3, the multiplicity is 2, so it will. At 4, the multiplicity is 1, so it will. Last thing I will ask you is for the y-intercept. So to get that, you plug in 0 for all of your x's. Ooh, that wasn't very nice. Alright, what do we get? Is that right?
Was it? Cause I'm so
I got
confused.
108.
Because wouldn't that be how wouldn't that be a
Times four,
negative?
28, yeah, it's 108.
Because you have a -3 times a -4, which makes it opposite. So this is like -3 times 9 times -4. Multiply those, that's -27 times -4.
Oh, got you.
Alright, so we plot this. I am not going to take too much time here. So this is our 108. I hit my x-axis at my 0, so that's -3 and 4. Our end behavior should start up here and end down here. Okay, so if we start up here, at -3, what happens to my graph? Bounces, which makes sense because I have to go through my y-intercept. Come back, and at 4 we go through. And then how can you confirm all that? Graph it and check. Okay. Do we need to do another inequality one?
Yeah, one of them hard inequality.
Okay, so you have to get a single fraction on one side with a number, or with 0 on the other. So if I just give you something like this, like that part A, we are ready to jump right in with what? Yeah, setting up our sign line. Set top and bottom equal to 0. If you had a number over there, you have to bring that over first and get a common denominator. We don't have a ton of time, so I'm going to do one of these. So we set top and bottom equal to 0. So if we subtract our 5, divide by 2, we get -5 halves. And +1/3. Okay, remember we're not getting real precise when we graph these, we're just plotting these things. Then we go to our calculator and we graph the original. You need parentheses around top and bottom. So top was 2x plus 5 over 3x minus 1. And what we're trying to decide is if it's positive or negative. So this one starts above the axis, so that would be, then it goes below, and then positive. So we have positive, negative, positive. Okay, then you have to look at the inequality to know which ones I wanted. I gave you less than 0, less than means negatives. Equal to means bracket. Do both of those get a bracket? You can't have 0 on the bottom, so 1/3 has to have a parenthesis. So it's a bracket, -5 halves, comma 1/3. Okay, I've got 2 minutes. Is there anything else?